galaxy is a collection of stars, stellar remnants, interstellar gas, dust, and dark matter that is gravitationally bound. The name is a translation of the Greek word Galaxies, which means milky and refers to the Milky Way galaxy, which houses the solar system. Galaxies range in size from dwarfs with fewer than 100 million, 108 stars to the largest galaxies known as supergiants with 100 trillion, 1014 stars, each orbiting its galaxy's center of mass. Galaxies are thought to contain an average of 100 million stars. According to their optical shape, galaxies can be classified as elliptical, spiral, or irregular. It's believed that the centers of several of them contain supermassive black holes. Sagittarius A, the name of the Milky Way's primary black hole, is 4 million times more massive than the Sun. GNZ11 is the oldest and furthest away galaxy as of March 2016. It can be seen as having existed only 400 million years after the Big Bang and is located 32 billion light-years away from Earth. Following a 2016 estimate that there were 2,210,012 or more galaxies in the observable universe overall and as many as an estimated 11,024 stars, the estimate for the number of galaxies in the observable universe was revised in 2021 to approximately 200 billion galaxies, 21,011. More stars than all the grains of sand on all beaches of the planet Earth. The majority of galaxies have diameters between 1,000 and 100,000 parsecs, or around 3,000 to 300,000 light-years, and are spaced apart by millions of parsecs or more, or megaparsecs. For comparison, the distance between the Milky Way and its nearest massive neighbor, the Andromeda Galaxy, which has a diameter of around 152,000 Ly, is 780,000 parsecs, is at least 26,800 parsecs, 87,400 Ly, 2.5 million Ly. The intergalactic medium, a thin gas with an average density of fewer than 1 atom per cubic meter, fills the space between galaxies. Most galaxies form groups, clusters, and superclusters through gravitational organization. The Milky Way is a member of the local group, which it and the Andromeda Galaxy dominate. A member of the Virgo supercluster, the group. These relationships are typically organized into sheets and filaments at the greatest scale, encircled by enormous spaces. The Laniakea structure, a much bigger cosmic structure, contains both the local group and the Virgo supercluster. Hendrik van de Hulst predicted in 1944 that interstellar atomic hydrogen gas would emit microwave radiation with a wavelength of 21 centimeters, and in 1951 this was confirmed. Since the Doppler shift of this radiation is unaffected by dust absorption, it can be used to track the motion of the gas in this galaxy. These results supported the idea that the galaxy center is made up of a spinning bar structure. Hydrogen gas could be found in distant galaxies with the help of more advanced radio telescopes. Vera Rubin discovered a disparity between the known galactic rotation speed and the speed that would be expected given the observable mass of stars and gas in the 1970s. Today, it is believed that the existence of significant amounts of invisible dark matter explains the galaxy rotation issue. Galactic interactions are relatively common and have a significant impact on galactic evolution. Tidal interactions during close encounters between galaxies induce warping distortions and may result in some gas and dust exchange. Two galaxies collide when they pass straight through one another and have enough relative momentum to avoid merging. The stars in interacting galaxies often do not collide, but the interaction between the gas and dust in the two forms can occasionally lead to star formation. The forms of the galaxies can be drastically altered by a collision, creating bars, rings, or tail-like structures. Galactic mergers are the most extreme type of interaction, where the relative momentums of the galaxies are inadequate to allow them to pass through one another. Rather, they slowly converge to create a single, larger galaxy. The original form of the galaxies can undergo considerable alterations as a result of mergers. Cannibalism occurs when one galaxy is significantly more massive than the other. As a result, the larger galaxy stays largely undisturbed while the smaller galaxy is torn apart. The Sagittarius Dwarf Elliptical Galaxy and the Canis Major Dwarf Galaxy are currently being devoured by the Milky Way galaxy. Within galaxies, a supply of cold gas that condenses into enormous molecular clouds is used to make stars. Starbursts, which occur when galaxies generate stars very quickly, have been seen in some galaxies. They would exhaust their gas supply if they kept up this pace in a period shorter than the galaxy's lifetime. Thus, starburst activity typically lasts only 10 million years, which is a short time in the history of a galaxy. Even though they were more frequent in the early cosmos, starburst galaxies are still thought to produce 15% of all stars. Dusty gas concentrations and newly born stars, particularly massive stars that ionize the surrounding clouds to form H2 regions, are features of starburst galaxies. Supernova explosions from these stars result in expanding remains that have strong interactions with the surrounding gas. These explosions set off a cascade of star formation that extends throughout the gaseous region. The activity doesn't stop until the accessible gas is almost gone or scattered. Starbursts frequently occur when galaxies interact or merge. M82, which had a near run-in with the bigger M81, is the archetypal instance of such a starburst-forming collision. Starburst activity is frequently seen as scattered knots in irregular galaxies. If a certain observable galaxy has an active galactic nucleus, it is deemed to be active AGN. Instead of the galaxy's stars, dust, and interstellar medium, the active nucleus emits a considerable amount of the galaxy's overall energy production. There are several different categorization and naming systems for AGNs, but those with lesser luminosities are referred to as Seyfert galaxies, while those with luminosities far higher than the host galaxy are called quasars. AGNs produce radiation across the whole electromagnetic spectrum, from radio waves to X-rays. However, part of it may be absorbed by gas or dust inside the host galaxy or within the AGN itself. Galaxies are characterized by a steadily declining stellar density as a function of increasing distance from their center, which makes measurements of their true extents challenging. Galaxies lack a distinct boundary by nature. However, astronomers have developed a number of standards for defining the diameters of galaxies over the past few decades. There have been efforts to describe the sizes of galaxies going back to Edwin Hubble's time in 1936. Due to the significant consequences in astrophysics, such as the precise measurement of the Hubble constant, the necessity for a standard for an accurate determination of galaxy sizes has increased since the introduction of big sky surveys in the second half of the 20th century. Over the years, several standards have been modified, with some being more popular than others. Galaxies have their own magnetic fields. They are powerful enough to be dynamically significant because they drive mass inflow into galaxy centers, modify the formation of spiral arms, may have an impact on the rotation of gas in galaxies' outer regions, and provide the transport of angular momentum necessary for the collapse of gas clouds and consequently the formation of new stars. In a process known as recombination, hydrogen and helium atoms started to form about 300,000 years after the Big Bang. Since no stars had yet formed, almost all of the hydrogen was neutral, non-ionized, and readily absorbed light. This time period is known as the Dark Ages as a result. Larger structures started to emerge from density fluctuations, or anisotropic abnormalities, in this primordial matter. As a result, frigid dark matter halos began to include masses of baryonic matter. The galaxies we see today gradually developed from these early structures. According to deep sky surveys, galaxies are frequently found in groups and clusters. Rare are the solitary galaxies that have not had substantial interactions with other galaxies of equivalent mass in the last billion years. Only around 5% of the galaxies in the study are truly isolated, but they may have interacted with other galaxies in the past or even merged with them. They may even still be in orbit around smaller satellite galaxies. Because no surrounding galaxies are stealing their gas, isolated galaxies can make stars more often than usual. That was for today. Thank you for staying with us. Don't forget to like our video and subscribe to our channel.